There are moments in astronomy when a discovery does more than add another object to a catalog. It forces scientists to question how the universe was able to become what it is today. One such mystery emerged when the James Webb Space Telescope looked deep into the distant universe. Instead of seeing only isolated galaxies scattered through ancient darkness, astronomers found something far more intriguing: groups of galaxies arranged across an enormous region of space. The structure appeared almost like a gigantic cosmic bridge, stretching across millions of light years. It was not a normal spiral galaxy, and it was not a single glowing object. Instead, multiple galaxies appeared to occupy the same ancient environment, creating a long, connected pattern. To the human eye, the arrangement can look strangely deliberate. And that immediately raises an unsettling question. Could something this organized really have formed naturally? There is no evidence that an alien civilization created it. Scientists are not claiming that Webb discovered an artificial construction. In fact, the real mystery is much more interesting. If gravity and dark matter created this enormous arrangement on their own, how did they manage to produce such a large structure when the universe itself was still relatively young? The object often discussed in this context is known as the cosmic vine. Researchers identified a large-scale structure at a redshift of about 3.44, containing numerous galaxies and several regions where galaxies appear unusually concentrated. At that distance, we are not seeing the universe as it exists today. We are looking billions of years into the past. That changes everything. The young universe did not have unlimited time to create enormous clusters and networks of galaxies. Gravity needed time to gather matter. Gas needed time to collapse. Stars needed time to form. Galaxies needed time to grow and merge. Yet even in this early cosmic era, enormous patterns were already taking shape. A single galaxy can already span roughly 100,000 light-years. But a large-scale structure can extend across millions of light-years, turning individual galaxies into tiny pieces of something much larger. So what exactly are we looking at? It could be a developing galaxy cluster. It could be a collection of galaxies connected through the cosmic web. It could be a filament where dark matter has created an invisible pathway for ordinary matter. Or there could be another explanation. Sometimes distant objects only appear close together because of the way we observe them from Earth. Astronomers therefore cannot simply look at an image and assume that everything in it is physically connected. They have to measure distances. They examine redshifts. They compare the galaxy's positions and properties. They determine whether these objects truly belong to the same ancient environment or whether the apparent pattern is simply a coincidence created by perspective. This is one reason the James Webb Space Telescope is so important. Webb observes infrared light, allowing astronomers to investigate extremely distant galaxies whose light has been stretched toward longer wavelengths by the expansion of the universe. Instead of only seeing the modern universe, Webb gives scientists an opportunity to examine earlier stages of cosmic history. And when astronomers look that far back, the universe begins to reveal something unexpected. It was already developing a framework. Galaxies are not randomly distributed throughout space. Over enormous distances, matter gathers into filaments, sheets, clusters, and walls, while gigantic regions known as cosmic voids occupy the spaces between them. Together, these structures form what scientists call the cosmic web. The strange appearance of structures such as the cosmic vine becomes easier to understand when viewed through this larger picture. The universe does not need an architect in order to create architecture-like patterns. Gravity can do it. Tiny differences in the density of matter existed in the early universe. Regions containing slightly more matter exerted stronger gravitational attraction. More material was pulled toward those regions, increasing their density even further. Dark matter played an important role in this process. Although dark matter cannot be directly seen, its gravitational influence helps shape the distribution of galaxies. Ordinary gas follows these gravitational structures, eventually forming stars and galaxies. Over immense periods of time, those galaxies trace the invisible pathways created by dark matter. From our perspective, those pathways can look almost like roads crossing the universe. And Webb is giving astronomers a chance to observe these structures during much earlier stages of their development. That is where the mystery becomes even more fascinating. Researchers have also identified thread-like arrangements of galaxies from a time when the universe was less than 1 billion years old. One such structure contained multiple galaxies spread across millions of light years. It was not necessarily a finished cosmic structure. It may have been something closer to a construction site. A developing region where dark matter had already begun organizing matter, while galaxies were gradually assembling along the same gravitational pathways. From billions of light years away, that process can look almost intentional. But nature does not need intention to create order. Gravitational lensing happens when the gravity of a massive object bends the path of light traveling through space. Imagine looking at a distant galaxy through a gigantic invisible lens. The galaxy itself has not changed, but the light reaching us can become stretched, magnified, or distorted. That creates an important problem for astronomers. A strange-looking shape in a Webb image does not automatically represent the true shape of the object. A line might actually be several galaxies positioned along our line of sight. A stretched galaxy could be the result of gravitational distortion. Two objects that appear close together in an image might actually be separated by enormous distances. That is why astronomers need more than photographs. They measure redshifts and compare the distances of individual galaxies. If several galaxies share similar redshifts and appear to occupy the same region of cosmic space, the possibility that they form a genuine structure becomes much stronger. This distinction is critical when studying something like the cosmic vine. If the apparent structure were simply a visual effect, then the mystery would become much less dramatic. It would be an example of how gravity and perspective can fool our eyes. But if the galaxies really are part of the same ancient environment, then the discovery becomes much more significant. It means the early universe had already developed large concentrations of matter. And that brings us back to the cosmic web. The cosmic web is not a physical structure made from solid material. It is a gigantic pattern created by the distribution of matter across the universe. Filaments connect dense regions. Clusters form where matter becomes especially concentrated. Vast voids occupy regions where comparatively little matter exists. Galaxies tend to appear along these dense pathways. The strange thing is that this enormous network began developing from incredibly small differences in the early universe. At first, those differences were tiny. But gravity has one powerful characteristic. Once a region becomes slightly denser than its surroundings, it can attract more material. More material increases the gravitational pull. That attracts even more material. Over time, small differences can grow into enormous structures. Dark matter acts as part of this hidden framework. We cannot see it directly, but its gravitational effects influence how galaxies are distributed. In a sense, the galaxies are like lights marking invisible roads. The roads themselves are the underlying gravitational structure. Webb is helping astronomers observe galaxies that formed when those cosmic roads were still developing. That gives scientists something extremely valuable: a view of the universe during construction rather than only the finished result. And this is where the cosmic vine becomes especially interesting. It may not be a gigantic object in the traditional sense. It could represent a stage of cosmic assembly. Instead of imagining a giant bridge floating through space, imagine a region where galaxies are gradually being gathered into a future cluster. The structure we see today may be only a temporary stage in a much longer process. Over billions of years, gravity can pull galaxies closer together. Groups can merge. Clusters can become more massive. Filaments can continue feeding matter into dense regions. The universe is constantly changing on these enormous scales. So the ancient structure captured by Webb is like a photograph from a very early chapter of that process. And there is another reason scientists are cautious about interpreting these discoveries. Astronomers must compare observations with theoretical models. Computer simulations can recreate how galaxies and dark matter should evolve under known physical laws. Scientists then compare those predictions with what telescopes actually observe. If observations repeatedly reveal structures that models struggle to reproduce, researchers have to investigate why. That does not automatically mean the laws of physics are wrong. The problem could involve incomplete assumptions about galaxy formation, dark matter behavior, star formation, black hole growth, or the conditions of the early universe. Sometimes an apparently impossible discovery becomes understandable after better measurements are made. Other times, it exposes something scientists did not previously appreciate. That is why Webb's observations are so valuable. The telescope is not simply producing impressive photographs. It is giving researchers new evidence about how cosmic structures formed and evolved. And some of that evidence comes from a surprisingly early period. Astronomers have found galaxies and galaxy groupings from epochs when the universe was less than 1 billion years old. These observations suggest that large-scale organization was already underway remarkably early. But there is an important difference between saying that the universe had structure and saying that scientists have discovered something impossible. The first statement is well supported. The second requires much more evidence. A dramatic image can make a structure appear mysterious, but science depends on measurements. Distance, redshift, mass, motion, density. All of these clues help determine what astronomers are actually seeing.